Oh boy. Yeah, so it's been a minute or a year or two, close to 3, since my 86 Trans Am actually ran. And it's actually been over a year since I put a video out on it. So, have you ever had a project sit around for so long, you don't necessarily get bored of it, but you get to the point where you're like, okay, it's been sitting around for 2 years already. Why don't we just go ahead and spend the extra money and do the extra things I want to do in the future? So why don't we just put heads in a cam on the L83 here, even though I wasn't planning on doing it. But it's been down for so long. I mean, might as well spend the money now, right? And that is exactly what we're going to be doing. Now, my main reason for doing this is just because, yes, the engine is out, and I did want to see what this car could do with just a stock L83. But what it comes down to is I want this thing to be I want it to be kind of worry-free, at least until, I boost it. So keeping the DOD lifters in here, the DOD cam, it's a little unsettling to say the least, especially if I'm going to be spinning this thing out to probably like 6,500 RPM. I mean, definitely now if I'm going to be putting a cam in it. But I pretty much got in contact with Matt over at Tune Time Performance, and he recommended a few upgrades that I could do to this thing. So for one thing, we're going to be pulling the heads off today. I'm going to send them over to Tune Time. They're going to put them on their CNC machine, give them a nice port job, as well as the cam. Matt recommended a nice turbo cam that they use on a lot of their builds, turbo builds with this exact 5.3 truck motor. So we're gonna go that route with the cam. They're gonna take care of the heads for us. And while I'm at it, of course, I'm gonna do the typical upgrades. We're gonna put valve springs in it, probably BTR valve springs, trunnion upgrade for the rockers. And then by that point, I think I would have spent enough money where I'm ready to put this thing in for good, and we can get to work on the transmission. So without further ado, let me set you guys up in a nice spot, and we'll start taking this thing apart. Now, before I throw you guys into montage mode, let's talk about these stupid GDI injectors. So last time when I kind of did the cleaning on the block, I tried to pull the rails out to kind of get all this scale out from around them, and I just couldn't get them out. They are absolutely stuck in there. Just before I started filming this, I tried prying on these again, and they absolutely do not move. So my plan right now is to go at it even harder. Probably gonna ruin the fuel rail, but I'm gonna try to yank them out one more time with a larger pry bar. If that does not work, my final plan is to just pull the heads with the rails and the injectors still in them, and I'm gonna try to tap them out from the back. Now that is most likely going to ruin the fuel injectors, so I guess we would probably add to the list a set of LT4 injectors and fuel rails as well. So I'm not gonna go through why this took so long. Basically, I pulled the heads off. They sat around, one thing led to another. I got busy with other stuff, and it's probably been like 8 months later at this point. But I got them back. They're ready to go on the engine, and I also have everything else I need to get this engine back together and back in the Trans Am. Now, these did go out to Tune Time Performance. They got a CNC port job, they got a valve job, BTR valve springs, and a little bit of a milling, just to kind of clean them up. Didn't get new valves, just have the cleaned up stock truck valves back in there. And the fuel system is pretty much going to be completely new now, because as you can see, and as you saw, as those fuel rails came off, they got completely destroyed. Those injectors were just so caked into the engine, had no choice but to just kind of yank them out. They had to come out of the heads, and unfortunately, everything got damaged in the process. Fuel rails, totally screwed. The injectors, almost all of them are completely bent, where they actually pass through the head to get to the cylinder, being this is a direct injected engine. So I went online and I picked up a set of very expensive LT4 injectors to put in this thing. So those are the injectors that would came on a Z01 or a C7 Z06. Also got a LT4 injection pump. So we're gonna pair that with our injectors. And I have my nice custom ground comp turbo cam from Tune Time Performance as well. I'm gonna kind of go through the specs on this stuff as we put it on the engine, but without further ado, let's just get into it. And we're gonna start with the DOD delete. So this is the bottom of the valley cover, and you can see we have a bunch of solenoids here. And the basic principle on how this works, we have these special, notoriously failing lifters with these springs on them. Some cylinders have these, some of them just have regular lifters. And what this actually does is just send oil pressure to these weird lifters, and it essentially shuts them off. So it basically bleeds compression off of that cylinder. So when you're going down the road, you're on the highway, and AFM kicks in, it'll boot out. I think it could go down to like a 6-cylinder or a 4-cylinder even, and it'll just bleed compression off of those cylinders and allow the engine to completely just kind of chug along as a 6 or 4-cylinder without having that like boom, 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 the dead cylinder kind of building compression and just like misfiring like crazy, feeling like you have a misfire. So that's pretty much how it works. We're not going to be using any of that anymore. So I'm going to be putting standard LS7 lifters in here, new lifter trays. And then for this stuff, I'm going to leave all this in here just for cost saving sake. Because once we actually plug the holes on the block, oil pressure is just going to come up and stop at those plugs. It's not gonna get into this anymore, so all this could just sit in there. It's just not gonna do anything. They do sell valley covers you can get that just have little O-rings in them. So none of this junk will be here. There'll be little grooves in here with O-rings, and then when you put that back on the motor, those O-rings will seal pretty much just like this, but it'll completely block the oil pressure off at the bottom of the cover. So it'll do the same things as the plugs. Remember the last time I opened a cam on an engine? So we could get our cam in. You know, let's go over to the bench just to be sure. So this is a custom ground comp cam from Tune Time Performance. This is a turbo cam. It's actually a twin turbo cam. We're in the 630s for intake and exhaust lift with 116 LSA. So it's gonna be a very, very smooth, by no means lopey kind of cam, exactly what I wanted, because this is a sleeper build. I want a nice, smooth, quiet, kind of sleeperish idle. It's got a shit ton of lift. Even though the turbos aren't going on the car yet, I still think it's going to perform really well, even NA, because especially with that 6L80 and that like neck breaking useless first gear, I think that's going to help us out a lot as well. But let's go get this baby lubed up and we'll get it popped in the engine. Why is it like it's hitting the back of the motor? Is there a rod in there for the GTI? GTI rod. I gotta pull the valley cover to get it out. Ah, damn it. Can you tell it's my first time working on one of these? All right, there we go. There's our GDI lifter. There we go. It's got this little basket it sits in to keep it from rotating. Its own little lifter tray. How adorable. All right, so we are finally ready to get the front of this thing buttoned up. We'll get the timing chain on, get the oil pump on, and get the timing cover back on. But before we do that, I do want to mention the cam phaser. So these engines use VVT, the Gen 4s use it as well, and essentially all it does is mess with the cam timing to give you like the best performance in all situations and the best fuel economy. The problem is once you run like a really high lift cam, especially in these engines, well the 5.3, the L83 in particular, from what I read, it has like the worst piston to valve clearance out of the bunch, out of like the LT1 or the L86, which is the 6.0 version of this. So when you're running a really high lift cam, you gotta lock this out because you don't want this moving around messing with cam timing if you don't have the piston to valve clearance to do so. So I already went ahead, pulled this apart and installed a Comp Cam's 0-degree lockout kit. All that does is install a little wedge inside of this to keep the phaser from moving around and doing its thing, and then all the timing and the tuning will be done, you know, in the software when we actually tune it. But that kit just essentially makes this a dead non-VVT timing gear. So the timing chain is in. I got the cam phaser torqued down to 48 foot-pounds plus 90 degrees. That was a new bolt also, by the way. Gave it a little spin. We're all lined up on our timing marks. And you can see cylinder 1 is right at top dead center where it's supposed to be. So let's pop a head on and let's see what we're dealing with for piston to valve clearance. So here's everything that I'm going to be using to check our PTV clearance. I got a giant tub of clay because that's all the store had. I got an adjustable pushrod checker. I have a modified stock lifter, and then I went and picked up this caliper that I'm going to use to verify the length of the pushrod once it's all dialed in and we get our numbers. I'm also going to be using these lightweight valve springs that I already installed in the head here, and what these allow us to do, as you can see, there's no tension on them. So the valves open and close really easily, and it's just going to make sure we get a really accurate measurement and we don't absolutely destroy our pushrod checker, because this thing is not designed to compress these beefy BTR double valve springs, or probably any valve spring for that matter. So now, even though I installed these lightweight springs and they're supposed to collapse before the lifter is going to collapse and obviously not damage our pushrod checking tool, I did go and modify one of the stock lifters that came out of the motor to just be a solid testing lifter. So all I did was take all the guts out of this, filled it with washers, and put the cup back in. And as you can see with the modified one, there's absolutely no compression there. Whereas with the stock one, that just presses right down. And what could potentially happen, even though we have those lightweight springs in there, if we go to test with one of these stock lifters, the lifter cup could potentially collapse a little bit before the valve spring actually does, and what that's going to do is give us an inaccurate reading, because the valve isn't going to be going down as far or opening as much as where it would once the lifter is actually pumped up and running in the motor. Therefore, actually showing more piston to valve clearance because the valve isn't going down all the way, and thinking that we're safe, and then we go put the motor back together, this lifter's pumped up, and that could be the straw that breaks the camel's back, and it's too much lift. We didn't catch it because the reading was inaccurate, and we destroy our engine. So before we measure this, I didn't actually explain what I'm doing here and what piston to valve clearance is, even though I'm sure a lot of you guys already know. Piston to valve clearance is just the distance or the clearance between the piston and the valve. Yeah, that's basically it. So when the engine's running, the exhaust, for example, the piston comes up, the exhaust valve is opening, it's pushing that exhaust out the exhaust valve. If the piston comes up too quickly, or if the valve doesn't close fast enough, depending on the cam timing and how the cam is ground. You could potentially run into an issue where the piston comes very close to that exhaust valve because it's not closing soon enough, or it actually makes physical contact and hits it. So what we're going to be doing here is putting some clay on each sides of the piston here. We're going to pop the head on. We're going to put the lifter in and the push rod, the rocker, all that. We're going to spin this over, and then we're going to pull the head off, and we're going to see the indent in the clay, and that's going to tell us the exact distance that we have between the piston and the valve at the closest point. So first thing, before I drop the lifter in on the valve that we're going to be checking, you want to make sure that the cam itself is on base circle. So all that means is that the cam lobe for the valve that we're checking is at base circle or absolutely no lift. So if you look here, this is max lift for this lobe. And if this was sitting in the engine like that, right now the valve will be fully open. But as we rotate the cam, that lobe is going to go back. We're going to end up on base circle where there's absolutely no lift and the valve is going to be completely closed. And this is important because when we measure our pushrod length, we have to make sure that the valve is completely closed. There's absolutely no lift, because if we were to measure the pushrod length with the cam off base circle, maybe the valve is just starting to open like a little bit, and we get a nice length, you know, we got 0 lash, and then the engine rotates over and it's on base circle, that pushrod is going to be too short because we measured it in the wrong spot. So you look right down in there, there is our cam lobe. You're going to see right there is the very top, and there is the back of the lobe. So that's base circle. We have absolutely no lift. I'm just going to start with the exhaust valve. This isn't going to be the problem one, but you know, you do want to check both. It would help if I put the actual valve we're checking on base circle, huh? Next up, we want to take our head gasket. We're going to drop that on there. Then we're going to drop our head on. And I'm just going to secure this just with 2 head bolts. Doesn't need to be torqued down. So next up, we're going to get our pushrod length. So what I'm going to do is start out at 7.8 inches, because the stock pushrod length for this engine is 7.850. But remember, the heads were cut. So the caliper set to 7.850. I'm just going to put the adjustable pushrod in here until I get it to that length. I'm going to drop that guy in there. Make sure our lifter goes down. Now that's pretty good. We have a little side-to-side movement, but there's no actual up and down lash. However, if I pop the light in here, I don't know if you guys could see that, but I'm putting a light in the spark plug hole. That exhaust valve is slightly open, so that pushrod length is too long. All right, that's actually 7.95. So it's like 5 thou less, but I mean, if that's the difference between the valve hanging open, I mean, I'm really splitting hairs at this point. Like, 5 thou isn't really going to make or break anything unless we're right on the edge. But I do want to get an accurate measurement. Yeah, that's perfect. Okay, so there's no lash there. Let's see. Is the exhaust valve closed? Yes, it is. Absolutely no light. So that little 5 thou difference made the difference between the valve being slightly hung open and being closed. So now I'm just going to rotate this guy over a few times. And yeah, just like I thought, we have absolutely no content. No, I hope I have content. Absolutely no contact on the exhaust side. So now let's just move the lifter over and we'll do the same with the intake. Same thing, let's bring it around. I'm just gonna come in here with a razor blade at the highest point, which is right around here. We just wanna split this. And woo, that is close. And we have, oof, we have like 16 thou. That ain't much. Okay, so what exactly is happening here? Now, I already spoke with a tech over at Comp Cams, and I already spoke with Tune Time Performance, because like I said, this is a comp cam, but it's Tune Time's special grind for a twin turbo application. Now, they have never had an issue with piston to valve clearance. I spoke with the tech at Comp Cams. He has never seen an issue with piston to valve clearance on this cam. They've cut this cam for them countless times, never had an issue. So we're not exactly sure what's going on. He did recommend degreeing the cam, which we're gonna do in a minute, just to make sure it was cut correctly, the intake center line is where it's supposed to be, and then we could rule the cam out. But essentially what needs to happen is basically one of three things. Either we gotta run like a stupid thick head gasket to bring that clearance up. The Comp Cams tech recommended about 60,000, so we got a ways to go from where we're at now. We can retard the cam somehow, which using a stock timing set isn't really an option. I don't even know if they make adjustable timing sets for these motors. I'm assuming they probably do. But we'd have to back the intake advance off a little bit, because what's happening is the piston's coming up and the intake valve is opening as that piston is coming up. So it's getting ready to pull air in. So it's opening sooner, and that's where the actual contact is happening. But that's just a characteristic of this cam. So by changing that, it's gonna alter performance a little bit. I'm not really sure. Plus we have to go and get the cam reground. So yeah, thicker head gasket, retarding the cam, or regrinding the cam with less advance, or the third option is just to cut the pistons and to make it fit. So before we do anything drastic, let's go ahead, get a degree wheel on this, just verify that the intake center line on the cam is where it's supposed to be, so the cam is ground correctly, and then we could go from there. All right, so we got our degree wheel installed, we got our pointer installed, I got a cylinder head back on with the head gasket just snugged down with 2 bolts, just like when we were checking with the clay before. I didn't install the push rod yet, and I did not install the rocker yet, because the next step is gonna be to put a piston stop through the spark plug hole, and we're gonna use that to find true top dead center. Now what this procedure is actually gonna do is measure our intake center line of the camshaft. We wanna make sure that the center line that we measure matches the spec on the cam card. And then from there, I could decide what I need to do. Hell, I mean, if the number's off, then the cam needs to be reground because it wasn't ground correctly, and then that's why we're having contact problems. Or if it checks out and it matches the cam card, then we just gotta either get a different cam with a little less advance, or just make it fit. Now, first step here is gonna be, we wanna crank this over just till we see the piston getting closer to top dead center, or approaching top dead center. That's like 3/4 of the way up the bore. Now I'm gonna put the stop in. We'll get that screwed all the way in. So now that we know our piston is coming up towards that stop, what I'm gonna do is zero out the degree wheel. And this is just gonna be our very rough top dead center guesstimate, because we know the piston's coming close to top dead center right now, so we're gonna zero the wheel out. Make a fancy little tool to do this. It's like a ratcheting little thing. You just unlock it and you can spin this. Of course I don't have it, so I'm doing it the really crude, probably damaging to the degree wheel way, but it's gonna work regardless. All right, so now that we're zeroed out, our piston's coming up towards that piston stop. We're just gonna slowly crank it over until we touch that stop. and that's it. We're pretty much dead on 60 degrees. So what I'm gonna do now is come in with a marker. I'm just gonna mark that green so we know where our first stop is. What we're gonna do now is go back the other way, and we're gonna hit the stop away again in the other direction. So very carefully, so we don't wanna ram the piston into the piston stop. And the one that came in this kit, fortunately, it's just like a hardened bolt with threads on the end. There's no like little round nub, so it's, no matter how careful you are, it kind of leaves indents in the piston. Okay, there we go. So we just stopped at 110, 115, exactly on 116 degrees. And now halfway between these 2 points is where our exact top dead center is gonna be. So what I'm gonna do now is go back the other way, get the piston away from the stop. I'm gonna go zip it out of the head. And what I'm actually gonna do is add those two numbers together. And we're gonna find the average. The average is gonna be exactly halfway in the middle, and that's gonna be our true top dead center. So we got 116 plus 60, 176 divided by 2, 88. So 88 degrees, 5, 6, 87. Yeah, pretty much right there. 88 degrees. Perfect top dead center. Now we're not done with the wheel yet. So now that we have the engine physically exactly at top dead center, we can loosen the wheel one more time and put it on 0. Yeah, to play with our pointer a little bit. All right, there we go. We are dead on top dead center. So now let's hop up to the valve train. So next up, we're gonna pop our push rod back in. Remember, this is our checker. That is our exact push rod length for what we're doing right now. We're gonna zip this guy down. Still feels good. I'm not going to torque this. There's really no need. I was just being picky before. But next up, we need to install our dial indicator on top of here, and that's what's actually going to measure our valve lift. And obviously, because these engines are aluminum, there's nowhere to stick the magnetic base for the indicator. So I have a piece of scrap steel right here. I'm just gonna just bolt it onto the side here. And then I'm gonna spin the engine. I'm gonna rotate the whole engine stand so our cylinder head is nice and flat, so we don't have the indicator trying to slide off the engine. Yeah, that'll work just fine. That is nice and sturdy. So what I'm actually trying to do is I want to get we want to rest the indicator on the top of the spring retainer. We want to make sure it's down far enough so when we rotate the engine and the valve opens up, we want to make sure that we're always making contact with the indicator. I also want to try to get it to be like the same kind of angle that the valve is going to be going down. I'll just get this in a rough spot and then I could kind of tweak it from there. So I'm just going to rotate the engine over and we'll just verify we're making constant contact. Oh yeah, it's perfect. It's not wandering. exactly where we want it to be. All right, so next step is gonna be to rotate the engine over until we hit max lift on the intake valve. So right now the valve is completely closed. So now I'm gonna turn the crank over and we're gonna see the valve go down and start to open. Okay, and now we're gonna go all the way down to the point where the valve is open and then it starts coming back up. So we should see the dial eventually stop and start going back the other way. Right there. So what I'm gonna do now is zero that out, because that yep, right there on zero, that's our max lift. So what I'm gonna do now is take two measurements. We wanna measure our degrees on the degree wheel, 50 thou before we approach max lift, and then we wanna do 50 thou after we already passed max lift. Then we're gonna take those two numbers on the degree wheel, we're gonna add them, we're gonna divide them, and that should give us our intake center line, and hopefully it matches the cam card. So right now the valve is closing. Then I'm gonna go forward again, because now, remember, we're approaching max lift, and we're gonna stop right on 50 thou. Let's take a look at our degree wheel. We are right at like 80, 81 degrees. I know my pointer setup is a little janky. You're supposed to kind of have it hanging over the wheel, but it's still gonna do what we need it to do. Now we're just gonna continue on. Approaching max lift. Up, we passed max lift, so now the valve's going back down, and then we're gonna stop at 50 again. And what do we got on the degree wheel? It looks like we have 138. We had 80 degrees, 50 thou before, and now we have 138, 50 thou after max lift. Add those together, we get 218. We divide that by 2. We got 109. Now that is a little bit off because our cam card says our intake center line is supposed to be 112 degrees. So we're like 3 degrees off. So just to be sure, I redid the procedure one more time because I have never degreed a cam before and I wanted to make sure that everything was dead on. But even if I was a degree off on the wheel or whatever, we're 3 degrees off on the intake center line. And like I said, I did it twice. I got the exact same number, 109 for our intake center line. That's the problem. I mean, from what I understand, please correct me if I'm wrong, the less intake center line, so say we have 112, 109 will advance the cam, meaning the intake valve is gonna open sooner than it's supposed to, because like I said, what's happening right now is the piston is coming up, and before the piston can reach top dead center and start coming back down, the intake valve is opening. And that's why it's very, very close. So the fact that this cam was ground with 109 degrees of intake center line instead of 112, and our piston to valve clearance is so close, you know, we're not touching, but it's close, that's the difference right there. If that was ground with the correct amount of center line, we wouldn't be having this issue. Now, with that being said, I did go out and purchase one of these tools because I was almost certain that the fact that my heads were cut, or for some other reason, would have been the reason why the PTV was so close. I mean, because you think about it, this engine, it came from a salvage yard. It supposedly only had 60,000 miles on it, and I don't really see anything that would suggest otherwise. But you never know. I mean, the thing could have like blew a head gasket maybe before it ended up in the junkyard. The heads could have been cut, and then Tune Time rebuilt them and they cut them again. So that could have been why. But degreeing the cam. That's our problem right there. So yeah, I did go and I picked up this valve relief cutting tool from Lindy Tool. And I definitely recommend checking them out, because if you are having a problem with piston to valve clearance and everything checks out, this is actually a tool that goes in place of the valve. You stick it on a drill and you could cut the piston perfectly in line with the valve to create clearance. So now I spoke to Dave over at Lindy Tool. Very, very nice guy, old school, hot rodding kind of guy. Spoke to him on the phone a bit, knew exactly what I needed for this. Unfortunately though, it looks like I'm not actually going to be using this tool. I'm going to hang on to it, but the issue is actually the cam. I was almost certain that the cam was going to be fine, but I mean, it just goes to show. I'm probably never going to put a cam in ever again without degreeing it, I'll tell you that much, or at least without checking the piston to valve clearance. Unfortunately, I guess that's all I got for you guys today. I got to get in touch with Comp Cams. They're probably gonna have to send another cam out. I'm sure they'll probably do it in a timely manner, but by the time I get that, it's probably gonna delay us at least another week before I get this video out to you guys. At least we know what's going on. Next video, we're gonna get the cam swapped out. We're gonna get the engine assembled and ready to go back in the Trans Am.